Greetings everyone, and today we are going to discuss about the electronic configuration. Electronic configuration can be defined as the arrangement of electrons in the suborbitals. Can be defined as arrangement of electrons in the orbitals of an atom. As we previously discussed about the arrangement of uh, electrons in an orbital, that in an orbital there can be maximally two orbitals. In an orbital there can be maximally two electrons, and in that case there are four major rules which are studied for understanding the configuration of electrons, the location, the position of electron, the location of electron within the orbital, and how these help in forming the valency as well as other characteristic features of electron. Now, in this case here, there is the first principle which was presented by a scientist. He was a German scientist and named this principle as Aufbau's principle. Aufbau literally means building up, bridging up. So in that case, he presented this idea, and Aufbau's principle says that electrons, the relative energy of electrons can be filled from the relative energy of lower orbitals to higher orbitals, which means that electrons with the lowest energy will be filled first, after which the electron with the highest energy will be filled after that. For suppose here we are having the electronic configuration in such a manner that shell 1 is having the orbit is having 1s, then 2s, 2p, 3s, 3p, 3d, 4s, 4d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, and then in the reverse process we are having the relative energies in such a manner that f is having greater energy than d, d is having greater energy than f, p, then p is having greater energy than s. In that case, so in this case we can arrange it in such a manner that 1s is having the lowest energy, then 2s, 2 is having higher energy than 1s, and 2p higher energy, 3s, 3p, 4s, and so on. We are having 20 different orbitals with relative subsequent amount of energy in which the electron are supposed to be filled. In that case, 1s, 2s, 2p, 3s, and so on till 8s, having the highest amount of energy, will have the number of electrons to be filled inside them. So this is what is said by Aufbau's principle. Now, Pauli's exclusion principle. Pauli's exclusion principle says that inside an orbital, no two electrons can have the same four quantum numbers. We have four quantum numbers: uh, principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Now, according to Pauli's exclusion principle, he says that two electrons inside an orbital cannot have all of these four four quantum numbers to be same. In such a manner that here Pauli's exclusion principle, we are having example of helium. Helium is having two electrons, electron 1, electron 2. Now, first electron is present in which shell? It is present in the first shell, of course. And what is the subshell? Subshell is S, due to which we are going to write it as 0. Here, same case here, because both are having same orbitals. So here, these are present in first orbit, S subshell represented by 0. And when it comes to magnetic quantum number of them is minus L to 0 to plus L, as the value of L is 0, then the value of magnetic quantum number is 0 as well. But when it comes to the spin quantum number, one of the electron moves clockwise and other electron moves anti-clockwise. One electron moves clockwise, other moves anti-clockwise, due to which we can say that these electrons can have the same principal quantum number, azimuthal quantum number, magnetic quantum number, but they do not have same spin quantum number, because the spin quantum number inside an orbital of two electrons is always opposite. The spin quantum number inside the orbital of an electron is always opposite. Is always opposite. This is what we say for the spin quantum number. Apart from which, uh, apart from which this is the case for all orbitals, that all orbitals are having same of all of the quantum numbers are same except the spin quantum number. Change in spin quantum number gives the opposite number of opposite quantum numbers. It is moving anti-clockwise, it is moving clockwise. So in this case, this is a condition in which the spin quantum number is opposite. N plus L or rule was given in such a manner that N represents principal quantum number, L the azimuthal quantum number. Now electrons having less N plus L value will be filled first. Orbitals having less N plus L value will be filled first. For example, we are having 1s and 3s. These are two uh, different orbitals. Now 1s is having its value is, now for suppose value of n is equals to 1, whereas value of L is equals to 0 because 0 represents s. Similarly, here we are having value of 3, value of a principal quantum number is 3, whereas value of azimuthal quantum number as 0. Now when we are gonna add both of these value, answer will be here 1, where answer of 3s will be equal to 3. Now in this case, the value of orbital 1s is less than the value of orbital 3s, due to which 1s will be filled first as compared to 3s. Secondly, if we are having a consequence in such a manner that here 3d 3d and 4p are two orbitals which are having the same n plus L value. So suppose 3d is having its principal quantum number 3 and azimuthal quantum number 2b2, and here 4p is having its value as 4 as principal quantum number and 1 as the 1 as the azimuthal quantum number. When we're going to add them, answer will be 5. Now both are having the same n plus L value, but here the in that case, if they are same n plus L value, then the orbital which is having less n value, orbital which is having the less principal quantum number value will be filled first. Here 3d is having less a value of principal quantum number, due to which it will be filled first. This is a rule. And now last but not the least, we are having Hund's rule. Hund's rule says the electrons inside the orbitals are supposed to be filled one by one, then the remaining number of electrons are supposed to be filled in pairing in such a manner that here this is 1s. Let's take example of oxygen or nitrogen. Nitrogen is having 7 number of electrons, 1s is having 2 electrons. This represents clockwise, anti-clockwise spins. 1s, this is 2s, and rest we are having the suborbitals 2px. We are having the orbitals 2px, 2py, 2pz, 2px, 2py, 2pz. In this case, 1s and 2s are having being lower energy levels are filled with these electrons, and as these are not having orientations orbitals, they are filled completely. Now secondly, we are having 2px, 2py, 2pz. These electrons, these orbitals which are supposed to participate in the valence bonding and chemical bonding, chemical reaction, they will have their number of electrons in such a manner that their remaining number of electrons will be filled one by one first. As there are three number of electrons, they will be filled one by one. One into px, one into py, one into pz. Now these are the number of electrons which would be filled first, after which the remaining number of electrons which are left behind will be the remaining number of electrons which are left behind will be added either from the px side or from the pz side. So that would be giving us the answer of how we can suppose to form the valency of electrons, as well as how the bonding of an electron can be made by the use of valency. In this case, the number of remaining electrons is 0, which means that here we are having three unpaired electrons, 2px, 2py, 2pz, in which 2px represents one unpaired electron, 2py represents another unpaired electron, and 2pz represents another unpaired electron, due to which its valency is trivalent. Trivalent. On the other hand side, if there is oxygen, oxygen is having its value as 1s, 2s, 2px, 2p, 2py, 2pz. Now in this case, these are having the complete number of electrons, and here number of electrons will be first filled one by one, one here, one here, one here, and the remaining number of electrons is one, which will be filled either from the 2px side or from the 2pz side. I am filling it from the 2px side, so it will become in this manner. So here the unpaired electrons are 2, which means its valency is divalent, and this is what is said by the Hund's rule, and that is applicable for both hybridized orbitals, like orbitals which form hybridization, as well as for molecular orbitals. But the condition here is that all of these orbitals should be degenerate. These orbitals should be degenerate. If the orbitals are not degenerate, the Hund's rule is not applicable. For suppose we are having two orbitals, this is 2s, and there's another. All right, let me just give another clear example. 2px, this is one orbital, and 3dxy, these are two different orbitals. Now 3dxy and 2px are not supposed to be degenerate orbitals. As these are not degenerate orbitals, there will be no formation of chemical bonding in as per Hund's rule. There will be no chemical bonding formed. So that's all about today's video. Hopefully we'll meet again another one.